Hi, everyone. My name is Christine Angelini, and I'm an associate professor at the University of Florida in the College of Engineering and in the Department of Environmental Engineering Sciences. Very fortunately, I also assume the role as the director for the new Center for Coastal Solutions here at the university. And I'm pleased today to tell you about this effort and how we are looking forward to future collaborations with the MES Center as well. So the context for us creating this center is that all across the state of Florida, but also the coastline of all of the United States, and kind of symptomatic of what's happening around the world, is that these coastal communities are being faced with a wide variety of different environmental crises. Near and dear to sort of our hearts as Floridian are the few sort of coastal hazards that I'm going to be talking about here, which includes harmful algae blooms. It's on a regular basis that we're seeing highlights in our newspapers about the frequency and duration of both blue-green algae blooms and also red tide off of the coast of Florida, increasing in frequency and duration. And actually, we have an active red tide going on in Southwest Florida at the moment. But also regularly pathogen outbreaks. This is just a sampling of some of the headlines that are in our local news, and it is not an attractive thing for our state in encouraging tourists to come and spend time here when this is what's happening to our newspapers, that we have kind of a regular occurrence of different types of fecal pathogens and things like flesh-eating bacteria in the waters at our kind of high value beaches. But also, we're dealing with a kind of a chronic effect of saltwater intrusion as a very low-lying coastal state sitting on a limestone foundation. We're extremely vulnerable to the impacts of sea level rise, occurring both kind of on a slowly gradual basis due to global sea level rise, but also during extreme storm events. And the creep of saltwater inland is wreaking all kinds of havoc on our coastal infrastructure, but also on coastal water quality and the security of fresh water, through the intrusion into groundwater sources throughout much of our state. So this is, kind of, you could think about these crises as happening on all fronts. And they're not only kind of unpredictable, we don't know how bad they're going to be or how long a given sort of hazard event will last. But generally, the perception for all of these, and kind of the data is bearing this out, is that these different types of crises are increasing in frequency and or severity. So they're becoming bigger problems for the sort of health and stability of our coastal communities. And they're anticipated to get even worse with future climate change, but also increased population growth that continues to be projected in our coastal counties here in our state and across much of the continental US as well. So unfortunately, how our coastal kind of communities are and the state and the nation are responding to these crises, it continues to be reactionary. And I would argue that this is largely due to three reasons. The first is that we really don't know what the source of many of these hazards are. In this case of sort of West Palm Beach that's shown in the picture here, we don't know if it's, wastewater treatment facilities that are over capacity in our urban centers, or it's septic tanks in these residential communities that are really kind of the source of, say, fecal pathogens entering the coastal waterway and making their way out into our beaches, for instance. Second, once these hazards start to form, we really don't know what the environmental controls are that make them relatively better or worse. And so in the case of fecal pathogens working their way into this kind of, into the intercoastal waterway here, we don't know what type of oceanic forcing conditions or upstream sort of watershed forcing conditions would cause those pathogens to sit around in our estuary or more rapidly get sort of ejected and kind of, diluted through their sort of removal into the coastal ocean. And finally, we really have a relatively poor handle on what some of the rippling effects of these hazards are on our coastal economies, on public health, as well as on this sort of the status and health of our critical coastal environments. So as a result of this kind of the increase in the crises, as well as kind of these unknowns and how to handle them, is that we're seeing widespread kind of environmental health and economic degradation along our shorelines. We're seeing widespread declines in the health and spatial extent of our coral reefs, seagrasses, oyster reefs, and marshes across the state. This is kind of our vital green infrastructure, and it's collapsing in front of our eyes. We're also experiencing a decline in the quality of health. When this is what our coastal residents see in the news, and they're not able to go take their dog on a walk on the beach that is a part of their kind of mental health and physical health routine, this really has kind of a direct impact on what our lifestyle is like, as well as kind of, the public health repercussions of getting exposed to some of these hazards as well. And finally, we're seeing the impacts in terms of a weakened economy. And this, coming from the costs of directly cleaning up these hazards and their rippling impacts, losses in tourism revenue of people not coming here when these events kind of take place, damages to the productivity of our fisheries, as well as losses in things like rental income for property owners that own homes on these kind of coastal areas, as well as a devaluation in our real estate that's kind of taking place as our coastal communities become increasingly vulnerable. So the real question that faces me as a coastal scientist and many of my colleagues here and our collaborators in other sectors is, how do we turn the tide and build a more proactive coastal hazard response paradigm? And can we do this? Do we have the skills to do this? And what I would argue is yes. I think right now we are in the perfect situation and context to start to go from this reactionary, sluggish paradigm to something that's more proactive. And the reason for this is that I think some of the transformational technologies are here, although we're looking to folks that may be participating in MIST to further augment the capabilities of technology. But I also, from spending a year of time on Zoom over the last 18 months, especially during COVID, I've realized that the stakeholders that we need to work with to turn the tide are really ready to move from being in somewhat of a siloed project by project type of framework to thinking more holistically and creatively about how we really start working together to build this more proactive kind of regime. And so this is really where the Center for Coastal Solutions here at the University of Florida really kind of finds its niche and in its intention. So the mission for my center, and it's really a center that's inclusive of faculty from across the university, is to leverage innovative technologies, applied artificial intelligence capabilities, workforce training programs, and a multi-sector collaboration to enable local communities, the state, and the nation to better track, forecast, mitigate, and prevent coastal hazards. And ultimately, on the back end of this, and as the sort of the major products and benefits, are to improve the quality of life and the economic health of our coastal residents. So some of our innovation spaces here in the center really fall in four main categories. The first is that we want to take charge in collecting excellent data through the creation of a next generation coastal monitoring system. And this really hinges upon our ability to serve as a central kind of clearinghouse and an integrator of data that's coming from many different types of sensing sources, and building this network in a collaborative way with leading industries and organizations. Second is about the generation of useful data products through applied artificial intelligence and modeling. So our goal is to not just let the data sit on the shelf and kind of accumulate into increasingly large files, but is to start transforming the data that's being collected and the new data that's coming in a more systematic way to unlock what the root causes and sources of these hazards are, to identify the people, ecosystem, and sectors that are most at risk to these hazards, as well as to simulate different types of solutions that might be invested in by communities in the state and the nation to rectify some of these contributing sources to these hazards, so we can better anticipate what a given intervention, what the benefits of it may or may not be. And third is really about designing and sharing what we're calling precision interventions. So it's actually taking these data products and putting them to use through collaboration with a variety of partners, ranging from the Department of Health to the Department of Environmental Protection, as well as community public health organizations, for instance. And so this is everything ranging from identifying the populations that are at greatest risk to exposure from some of these hazards, and designing public health programs to enable those communities to better weather the storm of some of these coastal hazards and experience reduced public health impacts. You can see our different sort of major spaces for these innovations, or excuse me, these interventions range from public health to ecosystem restoration, economic resilience strategies, improving how we communicate science and information about these coastal hazards and what people can do about it through more advanced science communication systems, but also tackling the source of some of these issues through the advancement of coastal policy. And from, as you can see from these different sort of general spaces, we are leveraging the kind of incredible comprehensive research and educational capabilities that's present across the University of Florida to really move the ball forward in each one of these spaces. And fourth and finally, is across all of these spaces is developing a transdisciplinary workforce and development program, so that we are, as our mission as an educational institution, are pushing students into the workforce that have the skills necessary to work within such a comprehensive system. So we are in actively sort of partnering with a variety of different entities to push this agenda forward, and the goals of this center listed here are just some of the different collaborators that we've already been working with. We are actively looking for new partnerships to further enrich the kind of research and education fabric of our center, and therefore encourage any of you that might be interested to reach out. And this is kind of the general vision of what we hope to do, is to collect data from a wide range of sensing platforms, push this data into our modeling and artificial intelligence system to again generate these kind of informed data products, and use these data products to drive precision interventions. So really what we're going out and doing in terms of actions are driven by high resolution monitoring of what's happening in our coastal, in the coastal zone in space and time. And we are piloting this in this coming year in Charlotte Harbor, the kind of first generation of what this system will look like, and introducing the first kind of pilot elements of this. But really the vision over the next 10 years is to start replicating the system that we ultimately fine tune and refine in Charlotte Harbor across the state of Florida. So we would love to partner with folks that may want to engage with MIST in a variety of ways. And this might be basically through how we advance, how we monitor the quality and behavior, what's happening to our coastal waterways, land, and I'll say air, as well as our social systems as well. So partners that might be engaging in MIST that, you know, could interface with the center could be through the development of high resolution, low cost sensing of key water quality parameters. We really need to know what's in the water everywhere all the time. So that ranging from targets that are different types of bacterial species, harmful algae, nutrients, especially ammonia, nitrate, and phosphate, to really especially related to kind of identifying upstream sources of nutrient loading. Hydrodynamics of the system and high resolution monitoring of how water's flowing through the coastal zone. And that's quite complex, given that that's a kind of the interface of the watershed and the ocean, and disentangling their relative forcing is a major challenge for us and research objective, as well as traditional water quality parameters like temperature, salinity, dissolved oxygen, and turbidity, and simply the water level, which is vital for understanding sea level rise and storm surge, for instance, and what it is, kind of how it interacts with the coastal zone. But we also care about what's in the air. And so detection of aerosolized algae toxins, as well as their degradation products, is something that we're, is how harmful algae end up sort of influencing sort of public health, is through their aerosolized toxin forms, or that's one pathway that we have particular interest in. Thinking about new approaches to detect early macroalgae in the coastal zone that can reach bloom status and wreak all kinds of havoc on the health of our coastal systems and waterways. We have a huge interest in developing cheaper techniques for mapping the bathymetry of dynamic areas in the coastal environment with high spatial and temporal resolution, as these kind of dynamic areas can have a critical feedbacks to how water flows. And finally, is thinking about measuring what the ecosystem effects are on water quality, and thinking about how the natural part of our coastal system is responding to shifting water quality. And so if you want to learn more about the Center for Coastal Solutions, I encourage you to reach out to me. My email is at the bottom, but we also have staff in development that are particularly specialized in corporate engagement, as well as reaching out to David and Toshi, who are collaborators of ours and affiliate faculty in the center, to learn more. So thank you for your time and attention. And that's all I have for today. Thank you.